Welcome back. This is Karen Timberlake's Basic Chemistry, Chapter 7, Section 1 on the mole. All right. Every chemistry teacher's got a little pet mole. I've got a stuffed mole on my cabinet, and a mole is a number. It's a huge number. It's a ridiculously huge number. If you were to have a dozen eggs, you learn even as a really little kid that a dozen is 12. Okay, there's 12 eggs in a dozen. A baker's dozen has 13. Okay, so if you were to say a score, I don't know if you know 7 years ago, but a score is 20 years. Okay, you can have a gross. A gross of pencils is 144. Okay, so there's all these numbers that are like this. A mole is just like a dozen. It's a huge, ridiculous number, okay? So, here's more. So you have a dozen eggs. 500 sheets is a ream of paper. And then you have a 144 pencils is a gross of pencils. 24 cans is a case of Coke, whatever, okay? So a mole is like that. It's a collection term. And I'll tell you what it is in just a second. So, again, collection term, 12 donuts, 500 sheets, 24 cans. So, what is a mole, Mr. B? Okay. A mole is equal to this number. And this number needs to eventually get somewhere in your brain. Okay. What you're going to see, it's the same number of particles as there are carbon atoms in 12.01 grams of carbon. This is named not by the fellow who discovered this, but it's named after a scientist, Avogadro's number, okay? And what you're going to find is that it's absolutely got to be one of the most useful things that has been discovered in the last 200 years about chemistry. And that is that in one mole, you're going to have a certain number of atoms, all right? If you look on the periodic table and you find the atomic mass of, say, carbon, it's 12.01 AMUs. Remember, an atomic mass unit is a nucleon. It's a proton or a neutron. Basically, it's if you take a proton weight and a neutron weight, which is so close, add them together and divide by 2, that is an atomic mass unit. And carbon, since it's a weighted average, is 12.01 AMUs. That's the mass number on the periodic table. If you take 12.01 grams of carbon, okay, so you could weigh this on a scale, you are going to have exactly 6.02214 times 10 to the 23rd atoms. Now, 10 to the 23rd means that there is 6 plus 022 and 20 more zeros after that. So this is ridiculously big, humongously big. If you were to take a small glass marble and give me 1 mole of marbles and throw them on the ground, you would cover the entire earth 2 miles deep. That's how many marbles you would have if you had 1 mole of marbles. So a mole is an enormous number, okay? But what you'll see is in the atomic mass units considered in grams. So if you take those AMUs from the periodic table and simply say, hey, I want 12.01 grams of carbon, you'll have 1 mole of carbon. You'll have exactly 6.022 times 10 to the 23rd carbon, okay? So it doesn't matter what you have. You can have a dozen eggs, you have a dozen donuts. Right? It's the same. You have 1 mole of carbon, 1 mole of sodium, 1 mole of gold, whatever. So if you, for instance, have a mole of carbon dioxide gas, you have 1 mole, or Avogadro's number, of molecules. Okay? If you have 1 mole of sodium chloride, you've got 6.02 times 10 to the 23rd formula units. That's the NaCl. If you have 1 mole of potassium sulfate, you have 6.022 times 10 to the 23rd formula units of potassium sulfate. Okay, pretty straightforward. Okay, so a mole of aluminum, you got it, 6.022 times 10 to the 23rd. So you've got to get this in your head. This is one of the memory things. This is one of the handful of memory things that I would ask you to know in a year. Okay, and so 1 mole is always equal to that very large number. Try to put it in your head. Okay, so because that 1 mole is equal to this, then it is also equal to 1 mole, and I can use it as a conversion factor. Okay, if I take any number and multiply it by the number 1, I haven't changed its value. But if I use a number 1 in a sneaky way, I can change its units. So for instance, what is anything divided by itself? 2 divided by 2 is 1. 10 divided by 10 is 1. Fred divided by Fred, that's Fred, equals 1. Anything divided by itself is 1. So 1 mole divided by exactly the same thing that a mole equals is equal to 1. So if I use this number, 1 mole over 6.022 times 10 23rd particles, I'm multiplying something by the number 1. I'm not changing its value, but if I have particles, okay, let's say I have 32,007 or whatever, 320,007 particles, I can multiply by this, which is just the number 1, not change its value at all, but cancel particles and change it into moles. Or if I had moles, I would use this one, 1 mole divided by moles times particles. Particles over moles is the same as mole over particles. It's just 1. Anything over itself is 1. I can get rid of what I have and change it to the other one. Okay, so how many carbon or copper atoms are in half a mole of copper? Well, I've got half a mole of copper. In 1 mole of copper, I've got 6.02 times 23rd copper atoms. So I simply I'm getting rid of this mole, so I put this one on the bottom. I put the other one on top, and now multiply, and I end up with the number of atoms. Okay, now stop this tape if you want to look at that again, because that's how you do it. If you're given moles, you put a conversion factor with moles on the bottom. Then you multiply. If you're given grams, or if you're given atoms, numbers of atoms, put the numbers of atoms on the bottom. Put the 6.022 on the bottom and put moles on top, and then cancel atoms, and you'll end up with moles. Whatever you are trying to get rid of, put that one on the bottom of the thing you're multiplying it by, and you'll get the other one. Okay. How many moles of carbon are in a certain number of molecules? Okay, so you have number of molecules. So I want molecules on bottom so that it'll cancel with molecules, and moles on top. Remember, this is simply 1. Anything divided by itself is 1. Now I'll end up with moles. So if you're given molecules and you want moles, divide by molecules. If you're given moles, divide by moles, and you'll end up with molecules. Whatever you have that you want rid of, put that same thing on the bottom of the thing you're multiplying it by, the conversion factor. The number of atoms in 2 moles of aluminum. Okay, well, I'm going to start with moles. So 2 moles of aluminum, and in 1 mole of aluminum, there's 6.022 times 10 to the 23rd atoms. Okay, so what is that? That's 2 times 6, so that will be this one, 1.2 times 10 to the 24. You'd need a calculator, but you can kind of do that in your head. 2 times 6 is 12. 2 times 6 is 1.2 times 10 to the 24. How about number 2? The number of moles. Okay, so I've got 1.8 times 10 to the 24 atoms. I want to get rid of atoms. In 6.022 times 10 to the 23rd atoms, I've got 1 mole. Okay, so I'm going to divide that out. And I need a calculator, sorry, can't do that in my head. 1.8 times 10 to the 24 divided by 6.022 times 10 to the 23rd, 2.989. Okay, so that's 3 moles. Okay. Subscript gives me the relationship in the molecule. Okay, so in glucose, I've got 6 carbons, 12 oxygens, 6 oxygens. Sorry, 6 hydrogens and 6 oxygens. So in one molecule, I've got 6 of these, 12 of these, 6 of these. Okay, in 1 mole of it, I've got 6 moles, 12 moles, and 6 moles. Okay, so in 1 molecule, I've got 6 atoms, 12 atoms, 6 atoms. In 1 mole of it, I've got 6 moles, 12 moles, 6 moles. Now, what's that mean? I took something that had 1 mole and broke it into a zillion moles? Think of it like a peanut butter sandwich. If I have a dozen sandwiches, how many pieces of bread do I have? Well, there's 2 pieces of bread in each sandwich. That means I need to take 2 and multiply it by the number of dozens. Okay, so if I have a dozen pieces of a dozen sandwiches times 2, I would have 2 dozen pieces of bread. Okay, well, in this crazy glucose, that's sugar, in 1 molecule, it would break into 6 of these and 12 of these and 6 of these. So that's 24 things. All right, that's 24 things that one thing breaks apart into 24 things. Okay, so if you're thinking of just in atoms, 1 mole of glucose will give you 6 moles of carbon, 12 moles of hydrogen, 6 moles of oxygen. Okay, so the subscripts is going to tell you how many atoms is in that molecule of that type. So here's aspirin, C9H8O4. Okay, so in every mole of aspirin, I'm going to have 9 moles of carbon. I'm going to have 8 moles of hydrogen and 4 moles of oxygen. Okay, but together I think of it as 1 mole of aspirin. Okay, because the aspirin has all of those little parts in it. So 1 mole of aspirin, and then if you broke it apart into its atoms, in that 1 mole of aspirin, I'd have 9 moles of carbon, 8 moles, and all I'm doing is taking the subscripts. That's it. Okay, so the subscripts can be used in conversion. In 9 moles of carbon, okay, if I have 9 moles of carbon and I know that there's 9 moles of carbon in 1 mole of aspirin, or there's 8 moles of hydrogen in 1 mole of aspirin, or 4 moles of oxygen in 1 mole of aspirin, I can use this as a conversion factor. Okay, and then I can change from, if I'm given this amount of aspirin, how many carbon atoms do I have? Okay, I can just use that as a conversion factor. Last one, how many oxygen atoms are in 0.15 moles of aspirin? Okay, well, I'm given 0.15 moles of C9H8O4, okay, and I know that in 1 mole of C9H8O4, I've got 4 moles of oxygen. Now, does that make sense? Because it's O4. There's 4 moles in that. Okay, this will cancel, and I'll have 0.15 times 4, so that's what, 0.6 moles of oxygen. All right, so beginning. I hope that helps.